Good day, everyone. Hi, and hope you are safe and sound. We're discussing a very interesting topic. This is our fifth session of our 5G series. This means that we are doing good and the engagement is growing session by session. So today we decided to talk today about how AI and ML can empower your 5G deployment, specifically when it's come to network slicing. So if you want to know how, stay with us. I'm glad to have you, Karim, again. And for the people who don't know us, my name is Mohammed Radwan. I'm the host of this series. I'm a chief architect and trainer, mentor, and emerging technologies evangelist. And with me, like a co-host, and he's participated in all the sessions so far, Karim Rabie. He's an ICT Chief Architect, and he was member of SDN, NAV, and he built a lot of frameworks and architect and big implementation for 5G. So as always, glad to have you, Karim, and it's your...
It's always a pleasure. So maybe we can just jump quickly to the content for the agenda. So today we are like coupling two important topics, the slicing and the machine learning. So we are starting with some foundation about the network slicing, about the evolution and the new concepts and how actually is being delivered currently. And then we add the machine learning ingredients and see actually what is the role of machine learning, how machine learning can help. This is across like the service level and going doing some zoom on the transport layer. So that will be actually our agenda for today. Let us remind our colleagues that they can always have the questions in the chat box, right? And we'd be glad to answer that. And if we have time, I think we can have a discussion maybe at the end of this session. Am I right, Radwan? Right?
Yeah, let's keep it because we have a lot of us today. So let's keep it under control. For now, post your question on the chat. And we have the first question for you, Karim. People are expecting to understand the AI, how it can support network access and core, and how's the learning, what are the sources of learning, and because it's important for a packet core background engineer. I believe we'll touch base on this point.
We are covering that for sure, not 100%, but there's one slide dedicated about the sources of data, and it is 100% touching the packet core environment. Yes.
Cool. So without further ado, let's go to the fun, Karim. Please tell us, Yani, why you decided to start with this slide. When I showed the presentation, I thought why we started the machine learning journey or the discussion with talking about the road to network slicing. Why not to go directly and talk about 5G? Why you brought us back till 2G and 3G?
One of the most challenges that actually face any kind of deployment efforts to machine learning or artificial intelligence based solution in any environment, and specifically in service provider environments, is actually the understanding of the use case, or what we call the underlying services. So the machine learning or artificial intelligence, for me and for many experts, they are like an overlay service that's actually applicable for a lot of use cases, right? But without understanding the real use cases, there will be no point actually to apply any kind of improvement framework, not even the machine learning. So we wanted to couple, or we wanted to explain the role of machine learning in slicing, but I just wanted to give a foundation about the concept of slicing, and that actually machine learning at the end can still be applicable to a set of underlay service, not only limited to slicing. So you will see in this slide some sort of slicing evolution, concepts like dedicated code, concepts like APN, concepts like even the packet core and the radio. So all these are running service, underlay services that can easily be enhanced, evolved by machine learning techniques. So this is why I just wanted to give a foundation about the underlying services.
Yeah, so as people can guess now, what we are trying to highlight here, that machine learning is not only for 5G. Machine learning and AI, you can even use it for, as we mentioned, in many use cases in many places, even for 4G or even 3G or whatever. So when you have a use case and you want your network to start using the machine learning to make a decision or adapt to a change, you can still use machine learning. Is that
exactly
true?
Exactly. So just let's start to give like a foundation, as I said, about the network slicing. So in in like, I wouldn't say in old days, but in back to 3GPP, like release 8, release 9, with the introduction of LTE. Okay, and even before the LTE, we used to have this kind of high-level logical architecture. Like you have the ETRAN, the 4G RAN, and you have the EPC, which is the core part, and you have like multiple services, like mobile broadband, some B2B services, some MMS, whatever. And you used to segregate these services by concept of APN. So when an enterprise customer comes, he gets an APN, commercial gets an APN, and you do some sort of also segregation in the radio through bearers. And then you start to, have trying to do different quality of service and assigning the right SLA to the right vertical. So this was some sort of slicing, because logically you were partitioning the network in a way or another. But it got more seriously with R13 and R14. This is the 3GPP release, and that's still in the 4G framework, by introducing the concept of dedicated network, which is DCN. So you see how the core network was splitted or fragmented to multiple dedicated core networks, DCNs, so that you start to provide a dedicated core network to a certain vertical. And when you do a dedicated stuff, then you give more isolation, then you start to give better SLAs and better, focus of one, better quality of service. But the operations gets complicated, right? Because you have now like multiple networks based on virtualization, most probably. And then you start to have like operation per stack. So operation for Mercedes, for BMW, for your customers. So the task starts to be heavy on the operations. With the introduction of 5G, that concept evolved to the 5G network slicing. So I'm a little bit conservative when I use the term. So for me, network slicing is a 5G term. So if you want to have the same projection on 4G, you have to use the term of DCN, or so it's like that. So with the 5G, you start to have the concept of the end-to-end slice. And when I say the end-to-end slice, so as you see, this kind of partitioning is actually doing this partitioning on the access network, which is the RAN, on the core, and even on the transport. So on the 5G, we have a framework for an end-to-end slice. And you started to get more isolation, because you start to get more dedication of resources to certain segments. And you start to have new terms like slice service type, SST, and that's something we'll see in next slides. But at the end, there are standard SSTs, slice service type, that point to certain verticals. So for example, whenever this customer moves to a roaming country or a roaming environment, he still gets the SLA characteristics that are corresponded to the SST. And the SST, for example, 4 is for V2X. So whenever a V2X or a vehicle like entitled to V2X, which is, this kind of vehicle to vehicle or vehicle to infrastructure communication. So whenever it roams across a global geography level, it still keeps the same characteristics. So these are the network slicing, and why it is important that what I'm going to conclude in this slide, because that's the new framework for monetization. Okay, so 5G is not about giving more data bucket and having nice like payment plans and whatever, and make people consume data more. For sure, that's the way that the legacy way of thinking, and this is still going. But when you have slicing, you can start to have like multiple slices on demand to enterprises. You can start to have new revenue streams coming from slicing, and that's something that we are going to show in the next slides.
Yes, I agree, Karim. So as you highlighted, that especially with 5G, we have this slice and network slice. It has like a lot of characteristic. It has a lot of requirement from the network, even RAN and transport. And as we will discuss now, we need to make sure that with machine learning and AI, how to keep track of this requirement, how to make sure that these 3 different networks is meeting the requirement for each slice, to make sure that the customer is happy with SLA. And as we discussed in the previous session, that actually the 5G, the target is more into the enterprise, because for 4G, I believe most of the revenue is coming from the residential or the phone users. Sure. But for 5G, you can create, as you mentioned, a dedicated slice for an MVNO, or create a specific slice for an enterprise or an oil and gas company. So you need to give them a strict SLA and preserve it. We have 2 questions so far, Karim. First question is asking about from infra perspective, how ACI, SDN, SD-WAN help here, or is totally different concept? I can give a quick answer and you can comment also, Karim. I believe these terms is more into data center and more into WAN connectivity. What we are talking about here is more into the transport and mobile core. So we have different terminologies and different solutions here. Karim, do you agree or you want to add something?
Yes, but on the reality, to be able to have this kind of dedicated slices, for example, you will have multiple virtual network functions to assign to each slice. So the underlying technology 100% will depend on SDN and NFV, right? So ACI is a commercial product. So let me use the term SDN. So NFV, SDN, yes, they will be used. SD-WAN is an enterprise service, right? So yes. some thoughts in the community and some approaches from the vendor that, okay, you are a mobile operator that offering a network slice. Why can't you also offer some sort of VAS, value added service, with the slice? So you offer, for example, a golden slice with some characteristics to the SMEs, for example, plus SD-WAN. So it's some sort of bundling. Okay,
yeah, yes,
but exactly. from standardization perspective, SD-WAN is not part really of the slice, yeah. But it can be bundled.
It can help, yeah.
And it is bundled, by the way, and some operators are going to this direction.
Yeah, I saw some telco actually bundling, as you mentioned, exactly bundling the slice with the SD-WAN solution to the end user, yes. And other branches. The second question, is there going to be a slice? Is there a slice dedicated for a UE yeah. in 5G? What could be the service required by the dedicated slice?
Okay, so theoretically, from standards perspective, each UE can have up to 8 slices. Okay, so yeah. 8 slices, UE can enjoy 8 slices. And yes, the answer simply is yes. This UE can be a user equipment, can be a handphone, can be a mobile, can be even a smart car. So yes, it can have a dedicated slice. And you will see in the next slide that there are a lot of flavors. And according to the commercial offering, is the operator offering dedicated slice or shared slices, grouping certain customers in one slice, or maybe dedicating slices for certain verticals? So the simple answer is yes, but again, it's according to the commercial offering. What could be the service required by dedicated slice? So it's all about SLA.
Yes.
It's not like the old days. I get a static IP address and I get access to some destinations and I block other destinations to my employees. Those were the enterprise requirements in the old days. But now it's about SLA. What kind of latency, what kind of throughput, what kind of quality of experience that I require in the slice. These are the parameters.
Yeah. We have another question, but I prefer to keep it to
the end.
This
one to the end.
Yeah, how to prepare to survive in this technology. So we will touch base on that.
Please, keep it
that's
to
why,
the end.
Yeah, that's why we're trying to, as a way of giving back to the community, as a way of educating the network engineers about these new trends. I believe this is keep learning and keep track on what's happening.
Yeah, so, and by the way, both of us, me and Radwan, we have the same background. We both are network engineers in a way or another. Okay, so we are all coming from the same background, so we try to give this kind of tips, but let's discuss that at the end.
Sure. So yeah, as you mentioned, Karim, we have a lot of flexibility when it's come to defining the components of each network slice, and it's up to the operator to decide how many components can be shared, how many components can be dedicated for this specific slice. It's more flexible than we saw in 4G and 3G. And I believe you prepared a couple of options, and then we can, at the end, we can try to do a quick comparison between the completely shared and the completely dedicated flavor.
Exactly. Yeah, I'm just putting a logical diagram, putting the main 5G blocks, like the RAN or the new radio, 5G new radio, the AMF, the access mobility function, like similar to the MME in the 4G, and the SMF, UPF, session mobility function and user plane function mapped to the P gateway in the 4G, PCF similar to the PCRF in the 4G, and the UDR like similar to HSS in a way or another. So this is like the ingredients of a typical basic 5G network. So all flavors, before I start, are acceptable. Okay. So the UPF, you can dedicate a UPF to a certain vertical or a certain customer. And this is very, very common in the early POCs and demos for the network slicing, because that's the part handling the user plane. So it makes sense that it is dedicated, maybe sharing all the control plane functions from the network. However, all other flavors are welcomed. Each time you add a node, you add more isolation and more privacy and more security and more strength to the tenant concept. You give more isolation to your enterprise customer, but you increase the operational headache, because each time you dedicate a node, you create it virtually, you operate it, you manage it, your team has to do that. So imagine that if you have, for example, currently 2P gateways running your commercial throughput or network, and then you start to have like 20 P gateway or 20 S gateway, each one assigned to enterprise customer, each one is demanding, each one is pushy. So it's a hell if you start to add a dedicated operational tool for each enterprise or dedicated stuff. This will never scale. So as the logic, every time you add a new node, theoretically it is acceptable. Standards does not block that. It gives more isolation and security to your enterprise customer. Maybe commercially this will be expensive, but it will still fragment your operational resources, because you'll have now to focus on multiple enterprise customers. Till we reach like the most aggressive dedicated slicing, where you even go to the RAN side, and in the RAN side, inside this RAN box, there are some sub blocks like the RU radio unit, DU distributed unit, and then the CU, the central unit. It has a control plane and user plane. So even the standards allow you to even allocate a dedicated CU user plane for a certain slice. So you can start from a UPF till almost you get everything dedicated to certain enterprise or certain customer. So the message here, all flavors are welcomed. Currently, most of the POCs and the early trials focusing on the UPF, but nothing prevents us on having a full dedicated slice to the customers or enterprise customers.
Yeah, I agree, Karim. So as you mentioned, we have like full flexibility, but we need as an operator to have like the trade-off,
Yes.
giving the customer a complete flexibility, a complete decoupling, and to avoid any feed sharing with any other slice, or the other side, when you have all this flexibility, giving to the customer all this better quality of experience to the customer, you actually imposing a lot of more difficult operation into your team to manage all these different components and to make sure that the life cycle and the health and of each one of them.
Exactly.
Actually, I have a lot of questions, so I'll go through them quickly, Karim. Some of this question we'll answer during our session regarding, as example, how AI can play a role in slicing. This we will see in the session. If by the end of the session we didn't answer your question, Amir, ask it again. How to have end-to-end slicing. This also will be answered during the session. How network traffic prediction will going to help us to decide the component for the network, like the amount of resources to be reserved dynamically. I think this is also a good one. We could answer it. Do you want to answer it now, this, Karim, or the next?
Let me just give some high-level answers, but they will be in the coming slides. Yeah. So about how AI can play a role on slicing. So we have one slide talking about that. Simply, there are two approaches. Okay, either the AI itself can be like an application. So you as an operator, you are providing an AI-based or ML-based application for public safety, monitoring cameras, COVID-19 detection, whatever, and then you sell it as part of the slice. So you give a slice to the government, for example, with an application based on ML. So you are selling artificial intelligence, and that's very basic. And this is covered in the big content about the artificial intelligence on the internet. The other role that AI can play, which is actually the operationalization of the slicing, because when you start to have thousands of slices, you have to have an autonomous system of operations to manage the lifecycle management of the slices, like designing, implementation, maintaining, healing, scaling, whatever. If you do that manually, you will never be able to scale. So that's the main role of AI in the operations aspects of the slice, on the lifecycle management of the slicing. And we will show that by one example. To have end-to-end slicing, what is the requirement? As per the book, as per the standards, slicing, mainly the radio slicing. So standards can give you, are giving you a framework to allocate a certain user plane in the radio to the to the end customer. So there is a framework for radio slicing. On the transport, Radwan will handle this part, but still the concept applies. You can have like dedicated whatever paths to, transport.
Exactly. Or an LSP or a complete new slice, as we will see in the upcoming slide.
And in the core, this is 100% covered by standards, and this is the focus now to give dedicated network functions like UPF, SMF together or separately to slice. So end slicing theoretically is realized, but the requirement should come from the business. Are you able to market this product? Do you have like a potential in the market to get slices to agencies, to MVNOs? So the focus or the realization should come from the business. Technically, we have the framework, but we have to have the push from the business.
Yeah, the business must realize first. Let me add, Karim. The business must realize the ROI because it will be an investment. This doesn't come for free. It's no free lunch. To have this end-to-end slicing, you need, even if you have the network, you need to have invest in system, invest in people, invest in orchestrator, as we discussed in one of our sessions. So business cannot go into this path without making sure what is the business use cases and what about the ROI.
Exactly. How network traffic prediction will going help in deciding the components for network slicing, like the amount of resources to be reserved dynamically. Okay, so resources optimization is one of the basic use cases of machine learning in the service provider environment. There is a nice document from ITU, from the Machine Learning for 5G Focus Group, talking about the use cases. And the resources optimization or resources reservation, this is one of the basic use cases there. So we will see that in the example. My example is about SLA assurance, but also I will talk about the resources in this one, just to cover this question. And then the last question, what about moving to the edge? Can AI support the nodes availability as part of the slice? Yes, whatever applicable on the core, applicable on the edge. So the machine learning, I will use the term even used in the ITU. It's a very overlay service. So it runs on whatever underlay service running, like core, transport, edge, whatever. The concept is the same, but it's all about deploying an end-to-end solution. So this also can cover the edge seamlessly, same as covering the core and the transport. So if you allow me, I'll just move to this slide, and then we jump. This is like the point that where we jump to the machine learning stuff. So with the network splicing, now we have like new concepts. Just quickly, we have something called communication service, which is the customer facing service. That's a new concept from 3GPP, but it was there in TMF. It was there for all people working on the BSS side, OSS side. So wherever you do it technically on the network splicing, it will be going to be mapped to a communication service or customer facing service that's going to be mapped to a commercial product at the end sold to the enterprise customer. So that's the link, right? Each customer facing service, each product maps to something called network slice instance, NSI. So NSI, that's a full end-to-end slice that it is constructed from 3 network slice subnets. As you see, there's a network slice subnet instance in the core, network slice subnet instance in the access network, and then there's a network slice subnet instance in the transport. 3GPP is covering confidently the core and the access, and there are other contributions like from IETF and other organizations doing the slicing in the transport. Some important notes that we have all to take it into consideration, and that will give us the impression on how it is difficult to operate an ecosystem that have dynamic slices. Why? As you see, like each single UE, theoretically can enjoy 8 slices. And people working on the core and the radio, they know this number, we know this number before, right? Because in the old days, the UE can only have 8 data radio bearers, okay? So UE can be served in 8 slices. So at any point, according to the application, the UE is enjoying, the traffic or the path can go from to slice 1 to slice 2 to slice 3. So it's not even slice per UE. You can have 8 slices per UE. Dynamically, from operator perspective and from commercial products, I can have 2 to the power 8 slice service type. Yani 2 to the power 8, like 255, right? Slice type. So slice for vehicles, slice for agriculture, slice for whatever. Each slice have an SLA as an SLA framework. And at the end, guys, imagine that like an Amazon, you are putting all this offering in a marketplace, and then enterprise customers go to this marketplace and select which slice fits his vertical, and then select it. And then when he selected, this can trigger multiple workflows that result at the end of the realization of the service up and running, and billing is starting. So it's a lot of orchestration stuff, a lot of operational stuff is triggered based on this click from the enterprise customer. 2 to the power 8 slice service type. In each slice service type, you can have 2 to the power 24 slice differentiation or slice differentiator. For example, if you have a slice for vehicles, you can have a dedicated slice to BMW, to Mercedes, to Volkswagen. So you have thousands of slices that can be on demand managed. What do you mean of on demand? Like enterprise customer, okay, require the slice. So it is instantiated. And then after like 1 day, it is on demand. So I want to delete it. It is terminated. If there's an issue in the slice, don't tell me that there is an operational team, human resources, will be able to manage all these slides and detect an alarm and then do an action. Because actually detection and alarm and doing an action, that's the old way of doing the operations, right? That's a reactive way. But the customers themselves, you will see next slide, they are paying for the SLA. So if the SLA is violated, you lost money, right? So you have to go to proactive actions. So all these inputs, all these facts lead to one direction, which is actually the last point. Automation and autonomous operation are the key factors, are the key ingredients to support this new wave of 5G services. We cannot tolerate the old way. We cannot tolerate reactive maintenance, because SLA violated, you lose money. So you don't want to violate the SLA, and you want to keep your customers. So that's the compelling reasons to have the machine learning flavor, artificial intelligence aid in the operations of network slice. I will take questions, but this is just support. I will finish my part here and then look at the questions. So we can conclude that we can have 2 flavors always for machine learning in service providers. Either it is a product that service provider is offering to the enterprise customer, like I'm giving you a slice with a solution for COVID-19 predictions. So it's a product, it's an application, or I'm using the machine learning to govern and empower these slices operations. I realize as an operator that I cannot do that the legacy way. I have to deploy the artificial intelligence techniques, and I'm focusing on the machine learning. There are for sure other paths and other streams, but machine learning in particular. And then I'm empowering my operations. I'm doing self-optimization of the network, ML-based. I'm doing proactive SLA assurance. I'm doing resources optimization. That was an answer for the question, using machine learning and all the other operational stuff. That's the compelling reason, and that's the flavors of the machine learning when it comes to service provider, or in particular, the network slicing. Do we have questions? Question about how are SSTs and SDs managed across multi-operator environment, or standards are still in progress to address the same? That's a very, very good question. So the purpose of having these SSTs is to have a global significance. So whenever you roam across multiple operators and you have the SST somehow allocated to you. So SSTs, like now they have like 4 standard values. Maybe now maybe they are starting to be 5, but the last time I reviewed R16, it was 4. So you have one for the EMBB, you have one for the ultra reliable low latency communication, you have one for the machine type communication, which is the M2M, and you have one for the V2X, vehicle to everything with anything. So if you are a smart car V2X, then you go with SST4 if you roam, you keep the SST4, so you are entitled to get the same treatment. So standards is pushing for that. If ML used to enforce a new slicing, were this application of prediction to be hosted? Yeah, that's a very good question, and this is actually the coming slide. Okay, I will actually talk about how the prediction can be made and where is it located. Okay. Okay, so we can just proceed. I'm just having a logical diagram. You can have, let me use a lather. So you can have multiple enterprise offerings, okay, that actually allocated for X enterprise, for 4K video broadcasting, to broadcasting agencies, to smart homes, to whatever. You can have thousands, okay, hundreds, whatever. And you have to maintain the metering and charging, but SLA based. So those customers will not pay time or volume. It's unlike the old days. They pay for SLA. So you have to have the system, the right system, the revenue management system that actually doing the SLA based charging. So that's an impact on the existing charging systems. But the most important thing that in the modeling of these slides, you have the slice characteristics ready and shown in a nice graphical interface way to the customers, that he can easily pick the slice that he wants. Maybe you can call it nice names like golden slice. And then he took, okay, latency, I need this number, delay, this number, priority handling, CPU overbooking. So you see there are also some requirements related to the infrastructure resources. Same like you book to Amazon. It's not just about the SLA on the service level, but maybe I don't want to have CPU overbooking. Maybe I don't want to share the infrastructure hosts or host aggregate with other customers. So there are a lot of characteristics to be put in place by the operator, okay? And we agree that the customer pay by SLA. And you have thousands of slices on demand by nature, and you have to make sure that this SLA is not violated, because if it's violated, you lose money. And that's the entry point I used to bring the coming use case. And the coming use case, again, I always say I'm a little bit conservative, so I like to bring things that are coming from standards, from communities. So I used to be part of the ITU machine learning focus group for 5G. So the guys there and the group there, and I attended some meetings with them. They're all working on some nice use cases, and all of them make sense because they are coming from the operators. So these are the use cases from the operators. So I picked the machine learning, SLA assurance, ML based as a selected use case for our session today. If we are all fine, we can start exploring this use case and see actually what is the ML contribution and how ML is enforced as a response to the question that was raised by one of the colleagues in the few minutes ago. Do we have question? We don't. Right?
No, I believe the flow is smoothly actually, and I enjoying what's happening. That's why I'm not interrupting a lot this session. As you can see, that this is just one of the use cases. I just want you to keep in mind this characteristic of each slice. So this will be like our aim. So we are trying to achieve this. We are trying to keep track of this characteristic. We are trying to make sure that the network is by doing a supervised learning, we need to make sure that we understand this requirement. So whenever we have any anomaly or abnormal behavior, we can quickly react to make sure we stay within the SLA. So yeah, I believe it's a very interesting use case, but this is not the only use case. Karim, as he said, he's tried carefully to choose the right one, which is making making sense and with the standard product.
Okay, so let's agree first that, okay, the network slice, as we said, the basic one consists of an access network slice subnet, transport slice subnet, and core slice subnet. But nothing also prevents the operation to have more innovative products commercially from market perspective, to add applications, to add value-added service. For example, you give the enterprise certain slice, and you give, for example, security as a service, firewall as a service, anything as a service. And that makes sense, right? Because you need always to bundle and bring more revenue. So let's say that the end-to-end network slice in our case is a slice in the radio, in the transport core, and an application. So from assurance perspective, from FMPM, we all know that this slice, 100%, it is virtualized. So there are some corresponding alarms and metrics are coming from the infrastructure. These alarms and metrics abstracted by any kind of tools, native tools of OpenStack, Kubernetes, VMware, whatever solution. But at the end, there are a set of alarms, raw data coming, alarms and metrics. And we have the network function alarms and metrics. We have, we all know the concept of element management system, right? Has been always there doing the FCAPs. So you also get some events and alarms and metrics from the network function itself. On top of that, a little bit higher, you have some sort of domain orchestration capability, or some sort of collection or aggregation that actually gets the metrics and give you some sort of KPI abstraction. So it's not just about the metrics. You have maybe another layer, maybe still in the same service domain, or maybe in the OSS. It's according to each organization, but you can get KPIs abstraction, not only alarms and metrics. This is achievable from the domain level. And also, maybe the application is coming with some sort of application manager. Let me use a laser here. There is no laser. Okay. Like some sort of application manager giving you the KPIs. So all these are nice data sources, okay? On top of that, on the higher level, which is perfectly fit in the OSS of any operator, you have some sort of end-to-end service KPIs formulations. You have the service quality management, SQM, which is a very well-known solution in the OSS, giving you the quality of experience, any degradation in the voice quality can be things there. And also you have systems for SLA assurance, like, this kind of Netcool, IBM, UFM, UPM, ProOptima. You have a lot of systems there doing the SLA assurance. And on top of that, you can have some sort of modern service order management capability, or end-to-end service orchestration with some sort of integration to the DOs and the orchestration in the infrastructure. So this is a logical stack of a service provider on how you can get the data, the metrics and alarms and whatever. So without machine learning, what is the case? The case simply that there are currently some automation solution and orchestration solution, and all of them are policy-based. What is policy-based? Policy-based is like, you put a static policy somewhere, static policy, saying that whenever a certain alarm or metric a threshold is crossed, like for example, whenever CPU reach 80%, whenever certain KPI reach 50%, it's an if statement. So whenever a threshold is crossed, you do an action, and this action is like scaling or healing. In that case, you do a closed loop control, but it's a reactive one. So you get the symptom, and then you, based on the static policy, you do the corrective action. So we agree that this kind of approach most probably will not scale. It is nice, it is automated, it's better than the manual intervention, but it will never scale with the new volume or the new wave of services. So how ML can help here? We will try to position some functional blocks.
Karim, maybe before discussing how ML will help here, a couple of points. I like this architecture, which is mainly, I believe, coming from ITU, but how to map these functionalities and these blocks to a normal or the normal groups within the telco. This is the first question. And how to assure the governance. I mean, each one of we have we have different team, radio team, access team, transport team. So how to assure that avoid this conflict between this team and assuring governance? So these are my two questions.
Well, it's a very valid question. And as I said, one of the obstacles on deploying not even machine learning, but even the automation solutions is actually the governance and the unclarity on the interlocks between the teams and the departments. So simply if we say like the transport, like core, most probably the metrics and the KPIs from the domain belongs to the domain itself. So that belongs to the core team, and that belongs to the transport team, in an easy way. So each domain is handled by the domain governor, which is actually the design or the planning team doing whatever technologies in this domain. On a northbound level, there comes the OSS teams, and the OSS, they have always the umbrella that collect the FM and PM from all EMSs from all teams. So this layer exists in the OSS. So this part usually is under the OSS team. Okay. And then there are some other systems not mentioned, like the revenue management and billing. So there's also some forking to the BSS side to do the metering and the charging of the slicing. Okay. Yeah. The end-to-end service orchestration, it's according to the organization. So if it is seen as the new OSS or new generation of OSS, then it makes sense that it actually belongs to OSS. Or if the organization is actually adopting a certain digital transformation, okay, so normally there is one team responsible of the end-to-end orchestration or automation across the organization. And when I talk about the machine learning, because I had a nice class with MIT about deploying machine learning in enterprises, and I focused for sure on the service provider. And one of the obstacles that I could note that actually the governance of the machine learning solution is not clear in the service provider legacy organization. Who can own that? Because the data normally, if I go to this step, the data normally is aggregated at something called like data warehouse or analytics department. So this department normally is very isolated from the functional teams. Yes. Yeah, the data aggregated in a department that actually has no relation with the functional team. So in order for them
usually not empowered to make a decision, or it's like a supporting function for the. I believe this team like core or transform, usually they have more power than this.
Yes, exactly. So it needs actually a clear charter, a clear direction from executive in the company, and that's, by the way, one of the clearly highlighted in that course, that in order to deploy machine learning, you have to have the buy-in from the executives. If you don't have it, it will never work. This is not technical stuff, but it is important. Okay, right. So you have a lot of data source, and symbolized by the term source. That's the source of data. Okay, they are all pushing this data to all levels to some sort of data aggregation, or if I may use the term used in the machine learning or the ITU documentation, it's a preprocessor. So you have data, but data not aggregated, not clean data. So you need to restructure the data. You need to make it in a format that can be pushed to a machine learning model or a machine learning solution. So this part always there in the data warehouse, in the analytics team or analytics department in any service provider. And then you push this data to a machine learning model. The machine learning model simply is actually consisting of two things: a machine learning algorithm, okay, and a stream of data used to train the model. What do you want to achieve? What do you want to achieve? You want to achieve a certain target that, for example, when a symptom happens, this means that something you predict that maybe the service KPIs will be degraded, okay? So you feed the data from both ends and you do the algorithm. And the duty of this guy is actually to understand the pattern that connect the data together, to understand that this thing, if this happen, it will predict what will happen, okay? So most probably in our environment, most of the data will be structured. It's easy to handle with. And most probably we will start with supervised learning. So you will give you will teach the machine learning by a supervised way. We're not going into details about this artificial intelligence terms. Yeah, you will have the data clean, inject to the machine learning using supervised learning. You have an algorithm and you have the data, and it is his duty to predict, to give prediction. And at the end, to output a policy. You remember the policy that we said that it is static, configured? No, this time the policy is dynamic. It's machine learning based, okay? So whenever things happen, this policy will trigger an action because it predicts that if I will not do the action, there will be a degradation in the SQM, service KPIs. So I will have to enforce an action. And that's the term distributor in ITU term. This distributor identify the sink, what we call the sink, which is the node where we are going to enforce the action. The best.
Let people guess, Karim. Where do you believe, guys, the sink makes sense?
Yeah,
Is
good
it
sir.
like
Yeah.
the domain abstraction? Is it, shall we put it on the core? Shall we put it on
Where yeah,
SQM?
exactly. Where can we
Where in
enforce
this
the
diagram
action?
you believe the sync should be? You can put your answer on the chat. Let's wait for a couple of seconds. So the question is, as per ITU, where you think the best place to put this sync function?
Well, ITU is giving the framework, but
yeah.
we have as people work in this community to map it to our stacks. Okay.
Yes.
So now machine learning successfully, it could predict that something will happen. So there's an action, a proactive action, not a reactive action, must be done. So where is the part to be enforced? Yeah.
Couple of good.
Yeah.
You mentioned OSS layer. To be specific, Karim, you believe it's
yeah, but it's right. I mean, it's a right guessing. It should be in the OSS. So yeah, 100%, it's a right guessing. So we believe that the solution will be completed by an integration with the end-to-end SO. So the end-to-end SO, for example, in that use case, will be the target of the machine learning output. So the action going to be there in the end-to-end SO, maybe that will result that end-to-end SO, for example, will go to the access network, do a healing action, or maybe do a proactive scaling on the core. Okay, this kind of actions are enforced on the or fed to the end-to-end service orchestrator. So that's how you close the loop in a proactive way, and that's how a machine learning can help you to govern and operate your dynamic slicing. And always keep in mind that you will have hundreds and maybe thousands of slices if you want really to have a monetization framework from 5G. Okay.
If you have this, your limited resources when it comes to your network, your devices, your bandwidth, and so on, you need to be very smart in assigning resources to the multiple slicing and keep watching what is happening. And based on what you can see on the ground using this feedback from the network, this closed loop, you can decide maybe if you want to change some specific slice to a different place or give it more attention and so on. Yeah. So I believe we have a couple of questions, Karim.
Yes.
One from our colleague Ram. Are we relying on NWDAV here, or we are using something completely different?
It can be. We can use the NWDAV. Actually, it is being referenced in the ITU document, but it can be also other boxes. So whatever data sources can help, it can be used. So NWDAV is a function, a 5G node having this kind of stats. So yeah, it can be used.
Yeah, and I would add here, Karim, an example for each layer, as I mentioned, maybe for 5G node, you know, in NWDAV. For transport, as example, we can use the old way like SNMP and NetFlow, or using the new way like telemetry, which can give you a real-time statistic about what's happening on the network. And then maybe you can decide, as mentioned, shall we talk to the network device directly or through the AMS? I mean, specifically for transport, we have different solutions for the analytics and AI. Some people prefer to communicate with the devices directly. Some other solution, they can integrate with the existing NMS or EMS solution. Yeah.
Okay, there's one question I would like to answer. Very, very good question. How the machine learning algorithm is going to learn? Will it be based on all past events and actions taken? Then when a new event happens, how it is going to correlate? As you know, there can be thousands of fault scenarios that can happen, and sometimes there is no correlation between them.
Yeah.
Okay, that's a very good question. So basically, if you have a function and you have input, okay, and you have the function, so you can easily drive the output because you have the input and you have the function. But in machine learning, it's a little bit different. You have the input and you have the output, but you want to detect or drive or draw or define the function. So training the ML model is like that. Why? You are giving the ML model inputs from all data streams, like for example, from infrastructure, from network functions, whatever, and you give them also the service KPIs. That's an example.
Yeah.
So the ML model will succeed to understand the pattern that connects the inputs to the outputs. That's how you train the model. So for you, maybe it's not correlated, right? Because, for example, CPU crash of a server fan. how can this be related to a degradation in VoLTE quality? Okay, we cannot correlate, but maybe by training, the ML model can see, okay, that there are other scenarios or other symptoms with other inputs can trigger the voice degradation based on the fan of the server. Just an example. So the ML model, that's his duty, to drive the function or to understand the pattern that connects the input to the output. So we give him the input and the output. This is the data that we provide to the machine learning model. For data aggregation, I think if it is integrated to OSS, I can get everything. Yes, yes. But till you reach the OSS, there are a lot of representation layers, a lot of customization happening on multiple layers just to have the format the OSS understand. So it's very, very helpful if you have the data source from all layers, like from southbound, from infrastructure till the service KPIs. This will bring data richness and will allow the machine learning model to understand the correlation between different layers. I think I'm done. The next slides, Radwan, we need to see the same on the transport. Let's zoom on the transport and see what's happening there on the transport.
Yeah. Yes. Thank you, Karim. So following the same approach, and to complete the idea which Karim was mentioning, if you can go to the next slide, Karim. I just want to show that usually, currently, that most of service provider, as a way of segmentation, as a way of having more control, and as we just discussed, that you have different team, and each team, they need to have their own policies and standard. They want to have their administrative domain. You can see normally in each service provider, in each telco, they have multiple domain like access, radio, or transport, and then the mobile core. Each one of them managed by different team. Each one of them maybe having its own. When we talk about transport, having maybe an MPLS domain, having a different IGP protocol, which is interior gateway protocol, and currently with automation, maybe each one of them is managed with a different orchestrator, and we have like the end-to-end orchestrator if you want to establish like a label switched path, or you want to establish like an end-to-end path from the core to the RAN. And with all these components, with all these different domain, where, as you can see here, this domain doesn't have full visibility about what's happening on the other domain. So this is from one point will make you having like a failure domain within your own admin scope, and also will not affect the other domain. Like we are trying to remove complexity from complexity. So with all these multiple sources, with all this multiple data, you need an intelligence to try to define the specific path meeting. Again, I'm just stressing again on the characteristic for each slice. So for us, the slice, the transport network is actually like a service provider, and the network slice or the mobile core slice is like a customer, and he has a specific requirement. And for us, just to carry on with what Karim mentioned, we need to make sure the transport network is always meeting these SLA defined by the specific slice. So as an example, if you go to the next slide, Karim. So as an example, here we have these 4 slices that defined by the standard, and we need to give each slice what is required. So as you know all that the EMBB as example is more interested or more worried about the bandwidth. So we need at least maybe to reserve a couple of gigs or 10 gigs, whatever, to this slice. So what we really care of here is the bandwidth, while other services like the ultra reliable low latency control is more into delay and so on, packet loss. So based on this, and in order to be able to build this thousands of slices over the network, we have something we call it like intent-based networking. We need the network to be smart. We don't want to go, as Karim mentioned, to define like a specific static policy, or also we call it in the transport like a service layer, where we define a specific requirement. I want my path, as example, to go from this node to the node .3 to 1 and then to the destination. Actually, I want to explain or preserve my slice characteristic as a business intent. So I will tell the network I need a slice for enhanced mobile broadband where it should have at least 10 gigabit per second. And as example, if I consider Australia, I want it to be direct from Sydney, Canberra to Melbourne. I don't want it to pass to Adelaide or so on. So just give this requirement as a business requirement, and the network is intelligent, taking into consideration all the data. If you remember the previous slide, all the data we got from the access, all the data we got from the transport, all the data we get from the mobile core. We're trying to collect this data, we're trying to validate it, and we try to create what we call it a single source of truth. And we need to make sure that this single source of truth is keep up to date. So we have something called single version of truth. So currently I have this picture of my network. So I need to have more like a real-time feedback from the network. That's why protocol like telemetry and so on will keep learning, adding to the learning and enhancement of my machine learning protocol by sending like a new picture or a new snapshot from the network every maybe 30 seconds. This is the standard now. And based on that, if you start clicking Karim, the animation. So if we decided as example that this is the initial pass I choose for the enhanced mobile broadband, and the blue one is the one I choose for ultra reliable and so on. So let's imagine at a point of time, this machine learning algorithm, when we start receiving this enhancement from the network, or we start detecting there is abnormal behavior for this orange path, then I say there's a degradation. So I will start giving some recommendation, maybe to move to another path starting from 1706 to 17,005 and 4. And this can be happen automatically. So in order to achieve this, I need to make sure that my data is accurate. My data is, I keep validating and keep assuring that the SLA, which the customer is looking for, the network is meeting this SLA, and I can provide even what we really see more to operate and to manage these thousands of slices. I believe machine learning will make a lot of sense when it comes to troubleshooting, when it comes to define, as example, the root cause analysis. Let's say we have a failure or we have a congestion into the MIOT or the V2X and affecting the traffic. So machine learning can detect all what's happening not only on this slice but on the other slices, and maybe we can consider actually there was some traffic caused by this blue path, which is really affecting some of the traffic for the orange. So I will say maybe let's move this blue path to another LSP or so on. So this in summary about what is the promise from the transport, that we need to make sure that we receive like the slice characteristic as a business requirement, and we want to make sure that with intent-based, I can actually intent-based provision the network, assure this deployment is meeting the SLA, and keep validating that I'm still keeping the SLA. And if I have something wrong happening, I can react automatically using a zero touch or a one touch provisioning, and I can keep updating the network and keep track of what's happening, which can also help in operating and troubleshooting my network. So this is in just few minutes, some few updates about how transport can complete the picture of what Karim discussed with us about the end-to-end SLA and how machine learning can helping in this specific case. And if you have any question, I'm happy to answer.
Thank you, Radwan. I think we have to wrap up because it's almost 1 hour. So
yeah,
yeah. So, would you like to give a yes?
Yeah, as you mentioned, Karim, as we promised, maybe you can allow the attendees to unmute themselves, and let's have maybe 5 minutes for your questions. If you prefer to have the freedom to unmute yourself and talk, it will be easier for you. So we are welcoming and happy to take your question.
Yes, and also I would like to add that whatever questions not answered in the session because of the time, we will just group that, and we will just post the answers together with the session, hopefully recording. So I'm just reading the questions now. Can be the new sync stack, can be one box solution. Well, normally the ML solution is somehow linked to what we call a sandbox. So you train the ML model and you have some sort of a sandbox to train the model and have the actions before going to the live environment. But the sync in reality, it's actually different. Can be anything. And for example, in this use case, it was the OSS or the end-to-end SO. But for example, the sync in some use cases can be the UE itself. So you send some action to the UE to lower the power, for example. So the sync can be anything according to the use case. In the last question, where is the industry in terms of end-to-end network splicing, in terms of deployment, and thanks. So the standards already governing that in R15 and R16, and the splicing is very coupled with the 5G standalone. So whenever you find a live standalone, which is actually we start to hear first 5G standalone, then splicing will be somehow aligned in the time frame with the 5G standalone deployments. Currently, we have a lot of POCs and demos.
Next question, Karim. Is there a 5G network launch commercially with such slicing end to end?
No.
Not yet. Yeah.
Not yet, but there are a lot of successful POCs. So we are ready to go live.
Another question, 5G going to make any revolution in ISP network as segment routing, etc.? I believe this question is for me. Yes, actually, we are seeing segment routing is one of the enabler for 5G. So in order to achieve this, what we call it network slicing on the transport layer, the best protocol you can use is segment routing. You can still achieve this using maybe something like the old RSVP traffic engineering, but it will be a very complex and it's not really, it will be more static. But segment routing, because it's can report different labels to the upper layer, and it's flexible, that allowing this upper layer to choose their path based on these labels. I believe it will, or what we call it SID, segment ID. I believe it's make many sense for a lot of the service provider to go for segment routing specifically for 5G network slicing.
Okay. I think colleagues, I think we can conclude, and again we will review the whole list of questions. Radwan, if any question not answered, even the ones answered, we can group them and send them to the colleagues, or even post it on LinkedIn. I hope the session was informative, and it's a new thing, a new technology, right? The 5G itself, it's a new technology. The machine learning in service provider environments, it's a new thing. So we are all learning. So thanks really for all your questions, and thanks for the contribution and the participation. I hope we didn't take the time for the Premier League for the match. So yeah.
We still have time to catch up the second match.
We still have time, yes, especially with the Classical. Yes.
Yeah.
So,
thank you all again, and please, I will try to post this video, the recorded session. Don't worry if you miss part of it. We will record it over my YouTube channel. We'll record it. I will share the link on LinkedIn, and please let us know what you want us to cover next. So once we post this, put in the comments what is you're expecting next, and looking forward to it. Thank you again, Karim. It's always pleasure to have you, and thank you all for attending and taking 1 hour from your weekend to be with us.
Thank you.